Hi everyone, welcome back. Today we are solving binary number with alternating bits. So we will be given a positive integer and we want to check whether the number has alternating bits, meaning that in its binary representation that the two adjacent bits will always have different values next to each other. So if you look at this example, 5 would be true because the binary representation is 101. 1 is different from 0 and 0 is different from 1. This will be false because 7 is represented as 111 and 1 is equal to 1, so we return false, and 11 also be false because it will be 1011. So although all these three are different next to each other, the last two are the same next to each other, so we still have to return false. So now that we have seen some examples, let's get to how we can solve this problem. So to solve this problem, we realize that the binary representation of a number can be represented using the remainders when we divide by 2. So we can divide the original number by 2 and get the quotient, and when we divide by 2, we also want to find the remainder. We will use the quotient for the next iteration and make sure that the remainder are always 0, and we will continue that until the number is divided into 0. And if all remainders are different, then return true, otherwise return false. So the full procedure would be to initialize a previous array to -1, and previous will represent the previous remainder. In the beginning there's no remainder, so we'll just say that's -1, and we will keep doing floor division by 2 and modulo by 2 until the number is 0 from the floor division. So each time we find the quotient remainder. If remainder is equal to the previous remainder, return false right away, otherwise we will set the quotient that we found to the new number and continue that until number is 0. If we have not seen anything equal to previous, then we can return true. So let's go through this example real quick. So let's say the number is 5, initialize previous to -1. 5 floor divide by 2 is 2, remainder would be 1. So we will set previous remainder to 1 now, and n is now 2. 2 divided by 2 is 1, remainder is 0, different from 1, so we can continue. And n is now 1, set the previous to 0. 1 floor division by 2 is 0 with a remainder of 1. 1 is different from 0, so we can continue, but n is now 0, so we can end the problem right now and return true. And the time complexity would be O of log n, where n is the size of the number because we're dividing by 2 each time, so the number of iterations will be O of log n. And the space complexity would be O of 1 because this is the only variable that we will be using, and the size of this will not depend on the size of the number, so the space will be constant. So now let's get to the coding part. So first we'll set previous to -1. Now while n is not equal to 0, we will continue it. So we will mod 2, and if it's equal to previous, return false. So now we will set previous to n mod 2, and we will floor division by 2 to set the new n, so n floor divided by 2. And if no remainder is equal to the previous one, then we can return true. See if it works. Okay, perfect. Hope this was helpful. Thank you all for watching. If you have any other questions or comments, feel free to leave them down in the comment section, and I hope to see you all again soon.